Thank you all for being here today. So I'm here to talk about Cassandra and Solr and really what you can get out of pairing the two and what benefits that Solr adds to any system that you're looking for. So a little bit about me. So I work with Solr and Cassandra and information retrieval. I work for a consultancy called Opensource Connections. We build search applications and discovery platforms, and really when clients come to us, what they're looking for is, how do I find my thing? How do I find what I'm looking for? Excuse me, what I'm looking for. And this can be any number of questions. This can range from the simple to the complex. And I guess just to get to know a little bit about each other, how many of you have ever worked with Solr? Oh, great. How many of you have worked with Cassandra? Excellent. So with Cassandra, when you're starting off to answer these questions, what it comes down to is that Cassandra really was not built for full text search. So if you're asking simple questions like who was Aristotle, where was he born, what are the coordinates of this place, then the answers are quite simple. All you're doing is just a straight select, and again, that's what Cassandra was designed for. When you want to start looking at more interesting questions, such as give me the list of all of the Greek philosophers, or talk to me about topics related to philosophy and thought, and any other tangents coming from that, then you can create an index on your column. You can search through the column, but this comes up with a number of problems. One, if you have any spelling mistakes, those will not match. Those will not make a match. Two, if you have a word that's similar to what you're looking for but isn't exactly it, then you're going to fall through. And if you're looking for any geospatial support, if you want to be able to say, I want to see all of the cities within 100 kilometers of this region, then you're basically at a loss, and you're going to have to find other things. Fortunately, there is a way. Search engines make all of these questions very answerable and very approachable, to where you can pull out birthplaces, you can pull out locations, and you can start to make inferences from all of those. And so now we're going to talk about, how do we even approach search to begin with? How do we go after what we're looking for? How do we find that information that we need? And typically, the people that come to us tend to go through a few different patterns before finally giving us a call and saying, we need some help. So they'll either set up just Google site search for their application to basically just run through all of their data, but this is not going to give you the customization that you're looking for. This isn't going to provide you with the level of detail and granularity over your data. There's always more nuance than just adding on a self-made solution. Or people will go with like statements using their MySQL database. And this will work up until a certain point, which may be anywhere from an hour to a day or even a week at most. But you actually see a lot of companies doing this, where they'll have these hacked together solutions to get them something that really isn't working for them. And so I'm here to talk to you about Solr and what Solr can provide for you, and also why this is a good match for your data in Cassandra. So Solr gives you a lot of power just straight out of the box. You get full text search, you get tokenization, you get faceting, and you also get a wide variety of aggregation functions. You can join, you can run sums, you can even run your own queries, your own functions over your queries when you're pulling back your data. And a lot of people use Solr. So this is just a handful from a list of hundreds. It's a top-level Apache project, and it's based on the Lucene search engine. Solr is basically just the wrapper around that adds in more functionality, adds in a server so that you can just immediately set it up and start connecting with it. So what is Solr? So Solr is what is called an inverted index. And the way that this works is that when data comes in, each piece of data is referred to as a document. And each term in that document is tokenized, chunked up, and then put into this inverted index. And so you can see right here that for each term, the frequency is denoted as well as which documents contain this term. It's basically the index from the back of the book. And this makes lookups very, very simple and very straightforward. Another very powerful tool with Solr is that you can define your own field types. So when information comes into Solr, or when a request comes to Solr, it's either one of two types. You're either indexing data into Solr, or you're sending up a query to extract information from Solr. And so you'll notice when you search on a particular field, you have two different filters that this information can go through. It'll either be analyzed through your index analyzer, or it'll be analyzed through your query analyzer. So your queries will get transformed in a certain way, and your index will also get transformed in another way. And the most common example is that when you're indexing data, you tokenize it, you chop it up just how you want it, and then you put that into Solr. And really what you're looking for is to distill all the information down into its key components. So you want to keep your index as small as you can and not bloat it out. So you remove stop words, you don't add synonyms, and you remove punctuation and stem the words back down to their original meaning. When you're running a query, on the other hand, you want to be able to find as much information as possible. And so what you do there is you add synonyms. So you basically double the number of terms that you're looking for. And just to give you an example of this, so you can see through this when a piece of information comes in to be indexed, the punctuation is stripped, stop words are removed, and then each word is distilled down to the initial meaning. Whereas when you're querying for this same phrase, you go through the same steps, except at the end you're also adding synonyms. And again, this improves the recall. This improves the number of documents that you'll get back from Solr. And in search engine land, when we talk about what is a good result, what we're looking at is precision versus recall. And it's always a trade-off between the two. Precision refers to, is this document actually relevant? Does this actually matter to me? And recall is the amount of documents in your entire space and whether or not you're actually getting a sufficient portion of those documents. And another really powerful tool that you get with Solr is the ability to facet. You can facet on any field that you index, and this is just basic grouping that really offers powerful flexibility to be able to create unique relationships and show unique relationships among the pieces of your data. So Solr is really great. But there are some drawbacks. What happens when you want to scale out? What happens when you want to distribute your data? What happens when you need to look at fault tolerance? What happens when you need to have a system that's constantly available? What happens when you have a real-world application that people are using, and this is getting hammered from all different sides? Well, there are a number of different steps that you can take. So if you're using Google's site search, you pay Google more money, and some magic happens behind the scenes. If you're like the rest of us, however, you've gone with something else. If you're using MySQL, you're going to shard out your database, and I don't need to tell you why searching over a sharded distributed database is a bad idea. Exactly. And with Solr, you also have a few different options. You have master-slave replication. You set up 1 or 2 or 5 different nodes that all point to their own supplicants, and so all of the data is replicated out. And this works great, except for the fact that when one node fails, when the master node fails, there's no way to know that that node has failed except for your own custom monitoring that you have over the system. And when that node fails, there's also no automatic switching around. So you'll have to go, you'll get that 3 a.m. call to go put that node back up and set a new master. Or you can go with Solr Cloud, which is the Solr community's answer to distribution and how we shard out data. And Solr Cloud is basically just splitting up the index and sharding it across multiple servers. It's still relatively young, a relatively young project, and there's still a lot of hiccups in getting Solr Cloud set up and setting up your own Zookeeper ensemble to keep track of all of the indexes. So it's promising, but this all points to the problem that this is a difficult solution. No one's really figured this out quite yet, and search is becoming more and more important in our society. We're a search-driven society. When you pull out your phone and you're looking for information, you're either typing into the search box into Google, into Yelp, into Google Maps, into whatever other application you have. There's always going to be a search box. And so what I am looking at and what we are really interested in is Datastax Enterprise Search, which takes Cassandra and Solr and pairs them together. And so not only do you get the full power of Solr with the aggregation capabilities, with faceting, with tokenization, but you also get the fail safety of Cassandra, and you get the ability to sleep well at night, knowing that your node and your cluster is up and running. And a little bit about Solr and Cassandra. So this started off as Lucandra, which was originally Lucene with Cassandra, and this was an open source project by Jake Luciani. And he eventually moved that into Solandra, also an open source project, before leaving for Datastax to start working on Datastax Search. And the premise behind that was that Cassandra was essentially just writing out to Solr every single time. Whereas here, with Datastax Search, what you have is you have Solr is the secondary index. The Lucene index is a secondary index in Cassandra. So next we're going to look at a little demo that I had brought up. The demo isn't online right now, but we're going to walk through some of the steps that I had taken. And basically, you're just looking at a straightforward data set of people and places, and then joining them up together at indexing time. And Aristotle, of course, was talking about the inherent duplicity of data. How do we represent hierarchy in a flat system? How do we combine different pieces of information to get a rich data set? And when we put these into Solr, we get the ability, we can run our straight searches, we can query for whatever we're looking for, and we can get back dates, we can get back places. And one thing that Solr does really well is date range faceting. So you can set facets based off of a particular date. So you can look at, over the past 50 years, who was born in 1980, 1990, and so on and so forth. And you can also filter by location. So this is looking within 100 kilometers of this particular point. And what you have right now is basically the ability to combine location and metadata and say, I want to know where philosophy was contained in the past 100 years and where it has popped up. And you can even see that progression throughout time. But of course, with any system, with combining of any system, there are always compromises. There are always decisions that need to be made. So the schema that I used for this was just a straightforward schema. And for those of you familiar with Solr, you'll see that I'm using a lot of dynamic fields. And this is because when you're pairing Solr and Cassandra, you don't get multi-valued fields. And these are exactly as they sound. This is just having multiple values in a single field in Solr. Really useful for lots of things, but we can mimic multi-valued fields with dynamic fields. And the process to set this up is very straightforward. You upload your schema and your Solr config into the cluster. And what happens here is that these actually are stored in Cassandra itself. And so all of your configurations are managed by Cassandra. This means that you don't need a zookeeper ensemble to keep track of all of the different nodes that are going up. You're relying completely on using Cassandra. And when you upload this schema, you also create at the same time a schema in Cassandra. So you get all of the fields that you've been looking for, along with a few more, and then indexes created on each field. And you'll notice a few other fields. So doc boost. So that's keeping track of what you are boosting in Solr. So when you're looking for a term in Solr, and when you're setting up your search engine, you can say that the title field is much more valuable than, say, the author or the tag field. And so you give that a particular boost. And this is just recording that. And the dynamic field, pardon me, is also recording, similarly, just which dynamic fields you've created. And you'll notice something interesting. You'll notice a Solr Query in this column family. And what this is actually how you can use full text search by querying Cassandra directly. So typically, when you're using Datastax Search, you'll want to just query Solr directly. But if you want to talk to Cassandra, you can also look up information using CQL by specifying a where clause with Solr Query equals whatever your term is. And this way you get the matching, you get the ability to be able to look through the tokenized information that's stored in Cassandra from Solr. And again, a few things have changed. So in Solr, you have no multi-valued fields, and you also don't have any joins. There's a little caveat here, because you never had joins in distributed search to begin with. But when you're running Solr on a single core, or on a single index, you can join across cores or across tables, essentially. And in Cassandra, you don't have composite columns, and you also don't have counter columns as well. And so ultimately, Datastax Search provides a real easy way of making your Solr fault tolerant and making your Solr highly available. With a few differences to your data model, you can really add a lot of availability and a lot of power to your system. So thank you. Are there any questions? Yes.
How do the Solr instances and the Cassandra nodes live? I mean, inside the machine? Because you don't have the same amount of Solr instances that the Cassandra nodes you will have.
They're both on the same machine, actually.
Really?
Yes. So what happens is that you have Cassandra on the machine and Solr on the machine, and any updates that go to Solr go through Cassandra first.
So how does that behave? Because from my experience, Solr is really slow when you update the indexes,
Mm-hmm.
and Cassandra is really fast. So in high writing systems, let's say,
So
how does that work? I mean,
it
works, because I'm really concerned about the Solr performance in that sense.
So the question being, how does Solr perform under high operations? Because Cassandra is a fast system, Solr is a slow system, it's throttled, is what it comes down to. It's generally, it builds up a queue. So what happens is you can hammer away at Cassandra as much as you want, and it'll filter into Solr. Because again, Solr is performant up into a point, but it's not going to be anywhere near the level of Cassandra. And that's also one of the really interesting points about this as well, is now you're actually opening yourself up to the potential of being able to access Solr in a way similar to Cassandra, or at least provide the buffer for that to be available. Yes?
I have a lot of questions on this topic.
Perfect.
Two, if that's okay. So a couple of slides before the end where you have that schema description. Yes.
Yes.
Two questions. Why compact storage? Because if I remember correctly, that's kind of being phased out from Cassandra, or so why I don't think it works. I don't think you can have a Solr-backed table without compact storage. So my question is why? Second question is why have those secondary indexes? Why do the secondary indexes get created when you enable Solr?
So those are excellent questions. So the questions were, why have compact storage? Isn't this being phased out of Cassandra to begin with? And then the second question was, why are there so many secondary indexes? To the second question, I'm not sure. I'm not sure why there are secondary indexes on everything. My hypothesis is that the way that this is structured is that any request that comes to Solr, that Solr is looking for, it looks up in Cassandra. It has everything indexed, but then it'll go and make a direct request to pull back that information that's stored in Cassandra. So that's my guess as to why. As to your first question of why compact storage, I'm actually not sure about this as well. I'm not sure if anyone else here would have an idea. And I'm also not sure that it's being phased out. No, that's great. Yes?
Can you talk a little bit more about the use of the Solr Query column? So can you walk up and say select star from location where Solr Query equals what you would, like a queue and an FQ and that sort of stuff, just a Solr Query as a string?
Actually, yes. So the question was, can you use Solr Query as you would a normal query into Solr? And yes, so you can add in parameters into Solr Query to talk to the cluster. It's not so this way is actually there are a few instances in which you'd actually want to direct your questions into Cassandra as opposed to Solr. Solr Query is there to provide the benefit of being able to access the same features, but you'll get the same thing from Solr. Yes?
I have also a lot of questions, but the biggest are on how Solr calculates the relevance. Is there TFIF or PM25, or how is the calculation of Solr?
So that's a great question. So how does Solr calculate relevancy? So Solr uses TF-IDF, which is term frequency inverse document frequency. And actually, I'll scroll back to the beginning. Here we go. To the inverted index. And so a really good example of TF-IDF is the concept of stop words. Is where you have words that occur frequently in a single document, and they also occur frequently in every other document. And so you have a very high term frequency, but you have a low inverse document frequency, because this is a word that appears everywhere, so it's kind of meaningless at this point. Whereas if you have a word that occurs in like a couple times in one document and then a few more times here and there, that'll have a higher TF-IDF because this is a word that's been keyed on as important. Yes.
The second question is, can I split the document corpus for different languages? Because so that I don't get the mistake that I calculate the wrong IDF value for different languages. So can I split them into?
So the question is, when I'm indexing multiple documents with multiple languages, can I split the documents so that the TF-IDF isn't calculated for all of them? That's an excellent question. So when it's not a cop-out, I swear. So when I think you might, if you want to get away from that completely, you'll have to create a separate core for the different language. But what you can also do is you can also split up each language into a different field type. So you'll have text for English, text for Japanese, and then depending on what you're searching over, you'll get the relevant results back based on that particular language. And again, relevancy and the scoring itself, it's useful. It's useless on its own. You never want to use the score for anything. It's only useful in the context of each other document and how they're ordered.
So back to the
Yes.
If a field is marked as stored true in a schema,
Mm-hmm.
is it stored in both Solr and Cassandra or just Cassandra?
It'll be stored in just Cassandra. So all of Solr's storage is Cassandra.
Except for the index itself.
Except for the index, that's correct. The index is Lucene. Sorry, yes.
So yes, back to the multi-language thing, because I was also going to ask the same thing more or less. So how does it behave in Cassandra? Then it creates a different key space for the language or something like that to keep things separate, because from my experience, having an index for Solr with different languages is a complete mess.
Mm-hmm.
Even if you have Latin languages which are similar, you can get completely crazy results. So how would you approach that? I mean, have you ever?
You mean how would I approach setting up different languages?
Website when you need to search in this architecture, let's say. Would you create like different cores, as you said?
Well, so this is a really fair point. So one of my last projects was actually with the Patent and Trademark Office, and they were pulling in data from the Chinese government that had been OCR'd and machine translated. It was interesting. It was an interesting experience. But here again, you have two different languages that people need to be able to index, and people need to be able to search over simultaneously. And so what we did there was basically we detected whether someone was searching in Chinese or English, and then we just said search over these fields if it's Chinese, search over these fields if it's English.
So you created different fields, as you said.
Yes. And again, the relevancy score, so that's something that we affected, that we changed in the configuration itself. So the English would get a much higher score on certain fields, whereas Chinese also much higher score on other fields. Relevancy with Chinese is a little hard to determine if you don't actually speak Mandarin, but that's a different story. Yes.
Will it work with the 8th resource, sort of the 8th edition of Cassandra, or is this tied to the enterprise?
This is actually only tied to Datastax Enterprise. So the Cassandra project was abandoned, and Jake moved on to Datastax and to work on this now. And there's quite a big team behind Datastax Enterprise Search. So there's no open source version. I want to say yet, because you never know what the future will hold. Yes?
You ever faced problem in doing partial updates using this bundle?
Using this bundle? No, actually, because the atomic updates in Solr work similarly. Because all that you would be doing, so this isn't something that I've done, but I've done this a lot in just plain Solr as well. And with an atomic update, the way atomic updates work in Solr is that they're not actually atomic. You're putting in one piece of information into Solr, but first you pull back the entire document, merge the two, and then reindex it. So you're actually not saving any time. I wouldn't see why that would be a problem with Cassandra Solr.
You know, the problem is that, well, we are doing it, and it doesn't really work very of the same name. And I think in this bundle they dropped one of the two, and I guess is the Solr one.
Yes.
In fact, I'm facing some problems, and I hope that someone else is able to, fix it or somehow find a workaround.
Yeah, so the Solr's transaction log was dropped, and they're using Cassandra's commit log. Could you talk a little bit more about that, about what issues you've seen with atomic updates?
Well, there's no more the atomic log, which is the recent thing we did in Solr 4, and that is used in order to do, the only thing that is used, that Solr relies on in order to do the partial update.
Which direction are you indexing? Are you indexing into Solr or into Cassandra?
Solr.
Have you tried indexing into Cassandra?
No, not yet.
That might be a good workaround solution, because you can access your column families directly through CQL and so on, and any other client. Yes.
What about Solr plugins? Is there any sort of compromise you're going to make there? Like query parsers and that sort of stuff.
I'm actually not sure. I would assume so. That's a really great question. With the plugins though, the way that you drop them in is you put them right into the right directory in Solr where they're located. So I'm not sure about that. Are there any other questions? Yes.
You mentioned other solutions that your clients use before switching to Solr and Cassandra. You didn't mention anything about Elasticsearch, for example. Like, is it something you sometimes use with some clients, or is like why choosing Solr and Cassandra?
So we use Solr and we use Cassandra separately. This is more of just a case study. But when I'm glad you brought up Elasticsearch. So Elasticsearch is similar. It's also based on Lucene. We use Elasticsearch a little bit. My experience with Elasticsearch is a little limited. So the only reason that I don't mention Elasticsearch is just for simplicity, without having to go into that, as opposed to Cassandra. Yes.
Has Solr any functionality to score graph values like PageRank or shortest path to use it for ranking?
Could you repeat that question?
Has Solr any functionality to calculate PageRank on a website search to rank them?
Does Solr have the capability to calculate PageRank search on websites? So if you mean that you're building a website search engine, then that's something that you'd have to calculate yourself. PageRank is closed.
Yeah, but so any graph calculation inside?
I'm sorry?
Solr hasn't any graph calculation.
Any graph calculation?
For link graphs.
I'm not familiar with those. But you can set your own scoring system. So you can write your own scoring methods. Any other questions? Great. Well, thank you so much, everyone, for being here. I really appreciate it.